experiment in your labs, and there are some terms that you may not know about. Okay, so I have written there the commands like tcp dot flags dot sync or tcp dot flag dot act. Okay, so I'll tell you each and everything about this header and how it will be useful, and what is the TCP header vulnerability that exists in our Linux environment. Okay, so right now that is being dealt with, but you have to understand the header to understand how each and everything is working in your in in networking. Okay, because most of the time whenever you are establishing a connection, there will be a three-way handshake in a TCP header. Okay, most of the time. Okay, so the UDP part is a different thing. In UDP you do not have to establish a connection, but it is not that much secure as TCP, and TCP is much more reliable than any other protocol. It means that if it is meant to send a message to the receiver, the message will 100% will be delivered. Okay, so there is no way, it's impossible for that message to be what do you say, lost on the way. Okay, so if it happens, if the message lost on the way, suppose this message is lost on the way, so what it do is this TCP send the same message after the timeout of this message. Okay, suppose this message was meant to reach here at 10 or 1 a.m. and this message was not reached here, because when the message reached at a sender machine, the acknowledgement is sent back. Acknowledgement means that I have received your message. Okay, so if at 10:02 the acknowledgement is not received by the sender, the machine will itself automatically will send the same message. It will send the message until and unless it receives the acknowledgement back. Okay, so I'll tell you each and everything how a particular communication between two sender and receiver machine occurs, and what are these things: source port, sequence number, acknowledgement, and what are these things. Okay, you will study these things extensively in your experiment, in any experiment. Okay, so it is very important from lab point of perspective as well, because these kind of terms will come in your software. Okay, so if you do not know what are these terms, it will be difficult for you to understand actually the communication, how the communication is working. Okay, now if you're seeing here, the header is totally of 32 bits. Okay, so total there are 32 bits available. 32 bits converted to bytes will be 4 bytes. Okay, so bits is denoted by a single small b. 32b is equal to 4 byte. Okay, byte is denoted by a big B. Keep that in mind. Okay, whenever you see the notation, when there is a small b, it means bits, and when there is a big B, it means bytes. Okay, we're seeing here all the. Just wait a second. What happened here? Uh, so all the header size, if you're seeing, wait 1 second. Okay, so if you're seeing here, this is of 16 bits, this is of 16 bit, it means it is of 32 bits or of 4 bytes. Okay, so again it is of 4 bytes, it's also 4 bytes. Everything that is written column by column, sorry, row by row, is of 4 bytes. Just keep that in mind. This particular option here, it is written that it can vary from 0 to 40 bytes. Okay, so keep that in mind, it can vary from 0 to 40 bytes. Okay, so it can vary between it, either it can be 0 or it can be 40, maximum of 40 bytes. Or data is optional. Data means that whatever you're sending. Okay, so if you want to send a message, this will be your data, and this data will be sent along all this header. Okay, it will be sent along with source port, destination port, sequence number, acknowledgement number, header length, or all these flags are being set or not set, and what is the checksum, what is the origin pointer, and option if it is needed. I'll tell you 1 or 2 options, but mostly it will not be used. Okay, so okay, only 2 or 3 options are used, but I'll tell you about it. Okay, so if you're seeing here, I can say that what is the maximum, I can say that what will be the minimum header length at this point. Just don't consider the data part right now. Okay, so I'm just considering that what is the, because data part is the part that you have to send, and if you're not sending that, the size of data will dependent upon the, what do you say, the negotiation that goes on between the sender and receiver. Okay, so sender can say I'm sending you 30 bytes of data. Receiver can say I cannot receive 30 bytes of data, I can only receive like 10 bytes of data. Okay, so our sender will say that I will sending you 10 bytes of data. Okay, so that data part is actually dependent upon sender or receiver, so we are not considering it, we are only considering the header part. Okay, so till here this is the header part. Okay, so I can say that what is the minimum header length that you can get. So if you count it, it is 4, 1, 2, 3, 4, 5. Okay, 5 times 4, it is 20 bytes, because in the options it can either be 0, because of the minimum part I'm considering the option part is 0, so it will become 20 bytes. Okay, another thing is that maximum header, how, what the maximum header will be, just add 40 into it, in the 20 it will be 60 byte. Okay, so maximum TCP header is 60 byte and minimum TCP header is 20 byte. Okay, so if you are considering any option, it will take the full 40 byte length, and the header length will increase there. If you're not taking it, if you're not taking the option, the minimum size will be 20 byte. Okay, so the TCP header length, you can say, varies from 20 byte to 60 byte. Okay, so it can either be in between, or it can either be 20 byte or in 60 byte, or it can either be like 56 byte. This can also happen. Anywhere in between number will also be fine. Okay, now moving on forward here, when you're seeing there is something called uh, this header length. Okay, so I just because I'm saying that the header length maximum can be of 4, either it's 20 bytes or 60 bytes. Okay, so I also have to tell the header length that we are transferring. Okay, so whatever you are sending, you whenever you're sending the data, you have to tell the header length of the whole TCP header. Okay, so how can you do it? Okay, just let me numerical part there, so I'll just copy and paste this one in this. So now the main part is that I already said that the size of TCP header will be varied from 20 to 60 bytes. Okay, but if you're seeing here, the header length only have the header length only have 4 bits. Okay, so if you're seeing here, the header length part is only containing 4 bits. Okay, so what are the maximum number you can get out of a 4-bit? What is the maximum number? Okay, so if you want to calculate the maximum number, so if I say that if there are 2 bits, okay, so if there are 2 bits, what is the maximum number you can get? Okay, so it will be either 0 0 0 1 1 1 1 0 or 1 1. Okay, so it is 0 1 2 3. Okay, maximum number you can get is 3. Okay, so if you want to see the formula, it is very simple. You just write 2 raised to power 2, the number of bits, this one, and minus 1. Okay, so 2 raised to power 2 is 4, minus 1, it is 3. The maximum number you can get is 3. Okay, so in a similar way, I can say that if I want to say 2 raised to power 4 minus 1 is the maximum number that I can get. Okay, so 2 raised to power 4 is 2 16 minus 1 is 15. Okay, so you're seeing here, you're only getting 15 part here, only 15 bits. Okay, so the maximum number you can get is 15, but the size of the header is written in the form of 20 to 60. Okay, so how can you do it? There is something called a scaling principle. Okay, just wait 1 second. Okay. So you need a scaling here. Okay. So how can you do a scaling here? Because there are only 4 bits. So what I do, uh, is that I know that what is the maximum length I can get is 60 bytes. Okay. So I know I don't only have 4 bits here. So 4 bits. So what I'll do, I'll divide this by 4 bits. Okay. So what I'll maximum will get, I will get 15 bits here. Okay. So 15, I'll get 15 from here. Okay. In a similar way, if I divide the scaling factor of 4, I'm using scaling factor of 4. I'll tell you what is it. Scaling factor of 4. Okay. So you divide the minimum length also, that is 20 by 4 here. Okay. So you will get 5 into 15. Okay. So what are these number meant here is that you can maximum represent up to from 5, minimum header length will be 5 and maximum header length will be 50. Okay. So what is meant by it? And when you are a sender, you're sending this header. In the header length field, there will be either be written from 5 to 15 numbers there will be written. Okay. So it is already understand from the sender and receiver part that we have done a scaling of 4. Okay. So it means we have done the scaling of 4 divided by 4 because only we have 4 bits. Okay. It is not more than that. So what I'll do, I divided the maximum size by 4. Now I'll say my header length right now is 6. Suppose I'll say my header length is 6. I'm sending this to the receiver. Okay. So receiver receive header length. Now what this receiver do is it multiplies it by 4 to get the actual header length. So it will be 24 bytes. Okay. So if the header length that is sent by the sender will be 15 and it is received by the receiver, the header length here will be 15. Now receiver knows that the scaling factor of 4 is used. So it will multiply 15 by 4 and it will get 60 bytes. Okay. So that is how the header length is dealt with. Okay. So whenever you are seeing the header length, because this is the first question that should came into your mind, because I already told you that the total size of the TCP header is between 20 to 60 bytes, but you cannot represent the number by using only 4 bits. By only using 4 bits, you can maximum represent 15 number. Highest number that you can represent is 15 by making all the 4 bits as 1. So this is a 15 number. So 15 cannot be represented in 20 or 60. So what we have done, we have scaled down. Okay. So we have scaled down by dividing these two things by 4. And now whatever you are sending here, it is received by the receiver and receiver just use the same scaling factor to actually get the header length of it. Because it is already being coded into the machine. You do not need to have, do not do a certain kind of thing. But whenever you are intercepting a particular TCP header, the header length will either be in the form of 5, from 5 to 6 to 7 up to 15. Okay. So again, you cannot say that there is 15 byte of header. You actually have to multiply whatever you are getting, whatever you are intercepting. Suppose you got the number 8. So you have to say that 8 into 5, oh sorry, 8 into 4, that there is a 32 byte header of TCP. Okay. So keep that in mind. So most of the time this particular thing is being mistaken by most of the people, that they do not know how the header length is represented. Okay. So most of the time they say that header length is actually represented by this number, but they do not know how actually it is represented. Okay. So I got into a bit deep because whenever you are intercepting a TCP header, you have to understand that whatever is written, it is not actually the thing. You have to scale it. Okay. So similarly, we have source port and destination port. So for source port and destination port, we are given 16 bits. Okay. 16 bits means that how much maximum number you can represent with 16 bit. You have to write 2 raised to power 16 minus 1. Similarly, 2 raised to power 16 minus 1. Okay. So what will be the number here? It is 65535. Okay. So it means these much ports are available on the source machine and these much ports are available on the source machine. Okay. So actually this particular thing will happen in your computer networks, in your operating system as well. So what we do whenever we represent the bit, everything we are doing in binary. Okay, keep that in mind. Everything we are doing in binary. When you got into operating system, there is a concept called paging. Okay. So in that paging, there is certain number. The paging will be given in the form of bits. Like suppose the page size that is given to you, in the operating system, the page size given to you is 2. Okay. So there will be other thing like physical length and other thing. We are not concerned with that. Suppose the page size that is given to you is 2 bits. Okay. So what actually it means, it is 2 raised to power 2. It is 4 byte page. Okay. So in computer networks as well as in your operating system as well, whenever the thing is written in the form of bits, you have to raise it to the power of 2 to get the actual length. Okay, so it means if there are 2 bits, how many maximum number possible with it, you can get 0 0 0 1 1 0 1 1. Okay, so the maximum number will be from 0 to 3. So how many pages are there? 0 1 2 3. So 4 pages you are getting. Maximum number size is 3. Okay, so you can get maximum page of what you say, number 3. Okay, keep that in mind. It will happen everywhere, the same concept. So everything that is being used in the header, like I was saying, that 16 bits. Okay, so what it actually means is 2 raised to power 16 bits. Okay, so it is the length of this thing. It means that you are available with 16 bits. How much maximum you can generate from 16 bits. Okay, similarly, if I say you are only got a 1 bit, so how much numbers you can generate with 1 bit? It can either be 0 or 1. So you are only generating 2 numbers and the maximum number is 1. In the similar way, if I say that you have 2 bits, so how much numbers you can generate with 2 bits? It is 0 0 0 1 1 0 1 1. Okay, so maximum number you can generate is 3. Okay, so similarly, if I say I have 3 bits. Okay, similarly, if I say I have 3 bits. Okay, so how many numbers you can generate with it? So it will be 0 0 0 0 0 1 0 1 0 0 1 1 4 5 6 7 7. Okay, 7. If you're seeing here, how many numbers I'm getting? 1 2 3 4 5 6 7 8. Okay, so with 3 bits you're actually getting 2 raised to power 3, 8 numbers, and the maximum number you are getting is 8 minus 1, that is 7. Okay, similarly you can go ahead and generalize this principle. Okay, so whatever there is written, these are the number of bits that are given, and from this number of bits, how many, what do you say, the counting that you can generate is the correct answer. Okay, so if I say I have in source port, I have 16 bits. Now what is the meaning of it? 16 bits means that how much port number I can generate. With the help of 16 bit, you can maximum generate actually 65536 ports. Okay, so this is actually the ports that you can generate, but the numbering will be from 0 to 65535. That is why I have to subtract 1, because it is starting from 0. In binary, it will always start from 0. That is why I'm subtracting 1 part. In a similar way, you will also get the destination part in the similar way. Okay, the source and destination numbers should be same, because without it there is no meaning. Okay, so if there are source, if there is more source port than the destination port, so it means that you are sending a message on a particular port that will not be available. Suppose there are 65535 port, and here there are 65538 port. Okay, so it is saying that please send the message on this is saying that please send the message on 65538, and that particular port does not exist on this machine. Okay, so that is why the source and destination port will always be same. Okay, will always be same. This is one thing. And moving on forward with one other thing is that there are what we have seen acknowledgement number. Okay. So acknowledgement number, you are getting 32 bits. Okay, so with acknowledgement number you are getting 32 bits. Okay, so it means the maximum number of acknowledgement that you can send is 2 raised to power 32 minus 1. You can calculate it out that what is the number here. It will be 655, it will be greater than 65535. Okay, so it will be a huge number here, just calculated with the help of a calculator. Okay, so what is acknowledgement number? Acknowledgement number means that suppose you're a sender and this is a receiver. You're saying that I'm sending some message, and the message will always be written in the form of numbers. Okay, so because we are doing everything in binary, so there is no way to represent those numbers. So it will be always in binary. Suppose this is the TCP header right now. In this, there is a sequence number field. Okay. So there are numbers, certain numbers that is written here, like 1111101, something like this. Okay. The starting sequence number of this is, suppose the sequence number is started randomly. So I've suppose it is started from 100 and you have given 50 bits here. Okay. 50 bits where it will be 150. Okay. So what is written in that sequence number? It is the sequence number field will be given the starting sequence. Okay. So it will be 100. Okay. So whenever you are sending a message to the sender, the sequence number field will tell you the sequence number that from which the sequence is starting. Okay. So what are these ones and zeros? Whenever you are sending a TCP header, there are certain things that are related to it. Okay. So it is source port, destination port, sequence number, acknowledgement. So whenever I say that the source port is suppose 20, I will not write 20 here. Okay. So if suppose I will say the source port is 15, I cannot write 15 here. How I'll write? I will write 1111. So 15 is 111 in binary. Everything will be here in binary and everything will be in number. So the sequence number field will contain that this particular, we are starting from the source port. The source port is started from a sequence number 100 until the end, whatever is the number here, sequence number, I do not know. It will be like 550, 100. I do not know. Okay, so I do not concerned with it. I am only giving the starting sequence number in the field, that is 100. Okay, so keep that in mind, that sequence number from the source will be started randomly and sequence number from the receiver as well, it is started randomly. Okay, so it is not like it is always start from one. It always starts from one. Randomly it is starting. To avoid there are many problems, if we start from one, the sequence number can be repeated. So that will itself contain a lot of issues. Okay, so I do not want to go into this issue because that issue you will study deeply in your networks. Okay, so I'm only telling you the basics of that, and when you go into networks you will get a lot of detail that actually what is happening here and why everything is as it is. Okay, so if I say why the sequence number is generated randomly, so you will study why it is generated randomly in networks. Okay, so I'm only touching the important part that you need to know in order to get the information that is needed in the labs. Okay, so just assume that the sequence number is started randomly. So there are so many things that you can make sense of by the sequence number. Okay, so previously it was again a vulnerability that we start the number from always one. So I can do a little bit of guessing and I can send the sequence number packet with the label 1 to the sender to overtake the computer. Okay, so overtake it was from that side. Okay, so just don't. Now it is just it is randomly generated on both of the side. Okay, so we have studied sequence number in the similar way. The acknowledgement is very close. Okay, sequence number is written here and then there is acknowledgement number. Acknowledgement number is nothing. Suppose you are sending I'm saying that I am sending the message. Suppose it is the header and it is written like this. Okay, so from 100 to 150. Okay, so it is you are sending this message to the receiver. Now receiver, when the receiver will receive it, it has to send something back. Okay, so it has to send something back saying that I have received your message. Okay, so how can it say it? Suppose now the receiver do not have anything to send. Just assume in this case the receiver do not have anything to send. So what it will send, it has received 100 to 150. Now it will send that acknowledgement. Now what is the meaning of acknowledgement? That I am expecting 151 from your side. Okay, so keep that in mind. There are two things here. One thing is acknowledgement number and one thing is acknowledgement flag. Okay, so ACK is the flag, ACK number is the acknowledgement number where you can write from 0 to 2 raised to power 32 minus 1. These number you can write in any of it, and whatever the receiver is getting, he will send the sequence number of the next expected byte. Okay, so I'll say in simple words, what is acknowledgement number? It is the sequence number of the next byte expected. Okay, next byte expected. Now what does this mean? That the receiver already received 150. Now now this is expecting 151 from the sender side. So that is why it is sending acknowledgement to 151. Okay. So this is acknowledgement number. Do not confuse it with acknowledgement flag. Okay. So keep that in mind. So we have done source port, destination port, sequence number, acknowledgement number. What is the sequence number? That you will have to give a sequence to everything that is being listed in a header. Okay. So you also have to give a sequence number to data as well, whatever you are sending a data. Another thing, acknowledgement number is that whatever you are expecting next from the sender, that you will send it. Okay, so either it from the sender side it can be sent, or from the receiver side it can also be sent. We have seen header length, and again there is reserved bit. There are 6 reserved bits, so you do not need to worry about it right now. These are being left here so that some added functionality can be added later. Okay, so right now there is no added functionality there, so these are reserved for certain things. We will not go into that because most of the time that is not being used. Okay? So now is the turn of a flag. So every flag is only 1 bit. Okay, so it means either it can be 0 or it can be 1 because of the 1 bit part. Okay, so how many flags are there? Urgent, acknowledgement, push flag, reset flag, sync flag, fin flag. Fin flag is finish. Okay, so there is a meaning of each and every flag. So I'll just write the number here so that it will be easier for you. I'll just write the flags here. So most of the time we will be using a sync flag, and there is another called acknowledgement flag. Okay, sync flag means synchronization. This is the first flag that is being sent from the TCP in order to say that I want to establish a connection with you. Acknowledgement flag is the back flag that is being sent by the receiver or a sender, saying that I have received your communication and I also want to establish a connection. So you can send back the acknowledgement flag. Okay, so I'll just give you a little bit of what do you say example that how the actual communication goes on. Now I will go a little bit deep here, that how this connection establishment phase, data transfer phase, and when you terminate the connection. So TCP is divided into 3 parts. The first part is connection establishment. Now you have to understand that how this works. Okay, so first one is connection establishment. Now then there is a data transfer mode. When the connection is established, you can transfer any kind of a data. Now then there is a connection termination stage. Okay, so that is why it is very reliable. The TCP is also known as uh, connection oriented protocol. Connection oriented that follows these 3 steps is referred to as connection oriented. And there is another term called connection less. Okay, UDP is connection less because it is not following these 3 steps. Okay, connection less does not mean that it is Wi-Fi. Keep that in mind. Most of the students confuse the connection less part with Wi-Fi. The connectionless does not mean Wi-Fi. It means that it is not following these 3 phases, that it is first establishing the connection and it is transferring the data, and then there is a termination of the connection. So UDP actually just start sending the message directly. It does not verify any of these things. Okay. So suppose this is a client here and this is a server. Okay, so most of the time I'm assuming the server port here, port number is 80 here, suppose it is 80, and port number that is being used by client is suppose X. Okay, so I'm using X. It can be any port. I do not need to worry about that part because I am opening my browser and sending a message. That is why I'm saying the server port is 80. Okay, most of the time it will be 80, or it will be 443. Okay, 80 is for HTTP, 443 is for HTTPS. Okay. So I most of the time it will be either of these two. Okay. Now say I'll send the first message to the server saying I want to establish a connection. So when I want to say that I want to establish a connection, what I will say my sync is 1. I want to synchronize with you. So this is the first flag that you have to do. Another flag is you have to also give the sequence number. Okay, so what is the sequence number here? Suppose you are sending from so you have generated randomly a sequence number here. So I'm generated a randomly 521 generated. randomly I've generated a sequence number of 521. So it is, suppose it is from 521 to any other thing, I do not need to worry about right now. Okay, so I'll see my sequence number is starting from 521, and then there is another thing called maximum segment size, and there is another thing called window size. Okay, these two things are a part of options. Okay, we are seeing here there is no window size. Window size, I think there will be there, but there is no maximum segment size. Okay, so this is a part of the option. Okay, so that I'm using. So there are two things here. Windows is referred to as a buffer. Okay, window is referred to as a buffer. So whenever two particular client and server are transferring data, so suppose this particular server, there is a difference between a segment and a window. I'll tell you about it. Suppose this particular what you say sender has 40 bytes available, the buffer, but it can send or expect, it can send or receive 40 bytes of data. Similarly, the B can also say that I have 60 bytes of buffer. Okay, so buffer depend upon the machine capability as well as the uh, network's ability. Okay, suppose this machine has 60 bytes of window size or buffer, and it has 60 bytes of window size or buffer. Okay, so this particular A can say that I can it directly do not send the window, the whole window, whatever is it is stored in like 40 bits. It does not send the 40 byte data to B. It says maximum right now, the maximum I can send you is 20 bytes. Okay. So B can say that suppose B's window size is less. Okay, suppose B's window size is less. So B can say that suppose it is only of 10 bytes. Okay, so B can say this is referred to as maximum segment size. Okay, so it is saying that it will not send the whole window at one time. It will only send a little. Only a part of the window size. Okay, that is referred to as a segment. Okay, so A say I can send you a maximum of 20 bytes. This is referred to as maximum segment size, MSS, maximum segment size. Okay, so B can say that I cannot accept 20 bytes of data. So it can say I can only expect, I can send you a maximum segment size of 10 bytes. Okay, so seeing the maximum segment size of B, the A can adjust its maximum segment size accordingly. Okay, so if you're seeing here, this is a negotiation that is going on. Okay, so again, the buffer of each particular sender or a client or a server will be different. Okay, so you cannot say that if I have 20 GB of buffer space, this client has the other server will also have 20 GB. Maybe it has less, maybe it has more. Okay, so that is dependent wholly upon the negotiation that we are doing. Okay, so that I'm saying that my maximum segment size that I can send you is 1460, and my whole window size at the time is 14600. Okay, so it's saying that I will send you what you say 10 byte. I will send you this particular data 10 times. Okay, because the maximum it can send at a time is 1460, and the whole buffer that is available to this particular client side is 1400, 14600. Okay, this is the meaning of it. Now that is why I'm writing each and everything that you understand here. Okay, so now again, the client will also reply. Okay, so the client will also reply with its own specification. Okay, so client will say it will again generate a random sequence, random port number, sorry, random sequence number. Suppose the random sequence number that is generated from uh, the sender server side is 2000. Okay, so I do not know, it is 2000, it is randomly generated. So it will send, first of all, it will say, I also want to establish a connection. So it will say sync equal to 1. And then it will also say that there is acknowledgement flag. Okay. So it will say that I have received your message, that is for this particular part. Acknowledgement, that it is sending the acknowledgement flag in saying, I have received your message. That is why it is acknowledgement equal to 1. and will also send its own specification. So it will say, suppose its window size at this time is like 10,000 bytes, and maximum it can send is 500 byte of data. Okay, so maximum it can send 500, and it's saying that maximum I will send 460. Okay, so now another thing is it will also send the acknowledgement number. Okay, so acknowledgement number, that whatever you are sending here, suppose there is nothing has been sent right now. The sent part is your sync sequence number, maximum segment size and window size. No data is being sent right now. Okay, so suppose it will say that I am expecting the next uh, see acknowledgement number of 522. Okay, so these are the things that it is sent, and it is expecting 522 uh, next from the client. And if you're seeing here, what is it says that it says MSS here tells you I can only send 500 bytes of data. Okay, so if you're seeing here, there is a kind of a negotiation going on. Okay, so it is saying I am sending first packet, sync is equal to 1. Okay, sync it with me. Another thing, I can only send you 500 bytes of data. I cannot send 1416 byte of data to you. Okay, so I cannot send 1416 or data, so 1460 byte of data. So the server here, if you're seeing here, the server here becomes the bottleneck. Okay, bottleneck means that the communication is totally dependent upon the server. Okay, because the client can send more amount of data, but the server cannot process that data. Maximum it can process is 500. So now the server here is becoming the bottleneck of the communication. Okay, so you have to set your standard according to that. Okay, so now the third part, this is the second part, first part, this is the second part, and now there is the third part here. Third part will be the three-way. To complete the three-way handshake, you have to set the third part. Okay, so you will say that, okay, I have received your message. I have received your message. How can it say that? It can say by acknowledgement equal to acknowledgement flag equal to 1, and it will say that you have sent me to 2000. So the next number I am expecting acknowledgement number, it will be 2001. Okay, because it has only sent the flags here, so it will only expect the next number I'm expecting is 2000, and it will also send its own sequence number. So it will set the sequence number to, because what is it is expecting, it is expecting 522, so it will say 522. So I'm ready to establish the connection. Okay, so what a three-way handshake is? Three-way handshake is first request, then you get a reply, and third you acknowledgement. Okay, so when these three steps are completed, you can say the connection is established. Okay, so here the connection is established. Okay, so any doubt till here? Okay. Okay, so there are so many things going on. I'm giving you a complete detail of how the communication works. So now the second part is your data transfer. Okay, so uh, it's very important that you understand how TCP works. Okay, so I know that it will totally make sense when you have studied all the protocols, but if you studied this one, everything will make sense to you as well. Okay, so now see here, now I have sent till this part. Now I'm saying I will also get a reply back. Okay, so now the data transfer mode will now start. So I also have to send the acknowledgement back from the receiver side. Now I can send that I want to send the data. Okay, suppose I'm at that time I'm sending only 100 bytes of data. Okay, so I can send 500, but I'm only sending 100 bytes of data. It means from 2001, the last bit will be 2100. Okay, so 2001 to 2100, I'm sending 100 bits of data. Okay, so what will I say here in the numbers? What will those number will be? Okay, first of all, I will say I have received your message, so I'll send the acknowledgement. Now what are the next message I'm expecting? So I'll say acknowledgement number. So acknowledgement number in this case will be if okay. So just let me start with the receiver here. Okay, just wait a second. So I'll start with this one. Okay, so suppose the connection is established, it will make more sense. Now the data is transferred from the sender side. Okay, so it will make more sense now. Now I will say that I am sending the sequence number 522, acknowledgement number 1, acknowledgement number 2001. Okay, so just suppose that I'm sending the data at this point. Okay, so data will be from 522.011.010, 522 to add 100 here. So we are agreed to 100 bytes of data. Okay, so maximum segment size is 1460. So I'm only sending 100. You can send 500 as well. So it dependent upon the sender. So I'm only sending 100. Okay, so just in order to make it easy. Okay, because if you have seen, it will make more sense if I have 100. Okay, suppose I said 100 bytes of data, because maximum I can send 500, because the client can receive 500. So I'm only sending 100. So 100 is also can be easily received by the sender. Okay, so now unless sender receives it, suppose this client does the server also have to send its own data. Okay, so what are the next number I'm expecting? I'm expecting a sequence number of 2001, and suppose it is also sending 100 bits, so it will be from 2100. So what I'll send back, now this is one important part that you have to understand. So first of all, I will say the sequence number part is 2001, that what I'm sending here. The acknowledgement flag will be one, saying that I have acknowledged, I have received your message. Another thing will be that acknowledgement, that what I'm expecting from you next is, because what is the size here? So you have received the message till 621. So you will say, I want to get 622 from your side. Okay. So similarly, again, this will go on and on, whatever you want. So the numbers can be set accordingly. So this is your data transfer mode. You can transfer the data any number of times. Okay, so just keep that in mind. These are some things here that when you do a sync and then you do a ACK. Okay, so depending upon the sync and ACK, you can say that this is which segment. Okay, so when the sync is 1 and the acknowledgement is 0, you can say this is the first segment that is being sent from the sender to the receiver. Okay, when the sync is 1 and the acknowledgement is also 1, this is your second segment that is being sent. Now, when the sync is 0 and the acknowledgement is 1, this is your third segment that is being said, third or after any other segment. Okay, because any other segment will contain ACK1. If you're seeing here, this is, I don't think this is third segment, but here the ACK is 1. Here the ACK is also 1. Okay, so when the ACK is 1, it mostly will be a third segment or any other segment after that. And if I say sync is 0 and acknowledgement is 0, this is not possible. Okay, because when you want to establish a connection, you have to say sync should be 1 and acknowledgement will always be there. So whenever you're sending some kind of a message, acknowledgement will always be there. Okay. So based on the number, suppose the sync is 1 and acknowledgement is 0, so just go on the starting. Here the sync is 1 and there is no acknowledgement that you are sending to the server. So that is why I'm saying this is the first segment. In the second one, you will got sync back and acknowledgement back. So the server will say, I got your message with the acknowledgement number 1 and sync number 1. So this is your second segment. After that, acknowledgement will always be 1 in every other segment. So that is why I'm said that it will be third or any other segment. Okay. So now the third step will be your connection termination. Here, there will be a use of the fin flag. Okay, fin flag. So I will discuss this in the next one. Okay, so any kind of a doubt till here, just let me know. Okay, I know that there is a lot of numbers here. You revise this one. If you are facing any doubt, just let me know. Okay, any doubt till here?
No, sir.
Okay, so thank you for listening. You can move on to the next one.